Okay, so we're going to go and start the quantum mechanical model. And so we just learned about the Bohr model, but research in the early 20th century, the 1900s, determined that actually the Bohr model, though pretty close, is actually not exactly correct. And what they found was, in fact, the more they discovered or learned about the electron, the less they realized they actually knew. And specifically, they didn't know exactly where the electron was. This particular video is really good. It's about 5 minutes, and it talks about whether electrons are particle or waves. Bohr thought electrons were particles. They moved around these fixed orbits. However, later, other scientists and physicists figured out that they were actually both particles and waves. And so this is a little strange. And if you don't quite understand what he's speaking about, as long as we remember that that electrons are both particle and waves, that's the biggest takeaway. So here are some scientists who came up with this. De Broglie was the first one. He predicted that all moving particles have wave and particle properties. The second one was Heisenberg. He came up with the uncertainty principle in the fact that it's impossible to know precisely both the velocity and position of a particle at the same time. And it's impossible because when you observe something, you actually affect the position and velocity of the particle. Let me explain. So let's say we want to observe an electron. But to observe an electron, you actually have to illuminate it. You have to look at it somehow. Even if you use a small amount of light, there's still light, right? And light is actually made of photons. So if we observe it, we need some amount of light, and light is made up of photons. So photons are light particles, right? Now the problem is, as soon as you observe it, these photons hit the electron, bumping it out of its original position or in a different direction, right? And so what happens is, as soon as you observe something that's really small, like an electron, the action of observing, because you need to illuminate it, and the bombardment of photons causes the electron to lose its speed and position. And so that's why it's impossible for us to even know exactly where an electron is or at what speed it's moving. Okay? And so that's what's called the Heisenberg uncertainty principle. And then lastly, there was a guy named Schrodinger. There's a famous thing about a Schrodinger's cat. You can watch it if you're interested. But he basically just said, look, electrons are both waves and particles, but we can use these elaborate wave equations to determine about approximately where it is, the electrons. This led us to our atomic model that we know today. No longer is it a fixed, like Bohr model, like these, where the electrons are, so no longer are these electrons in fixed orbits. But it's kind of weird, but now that we know more, we actually know less. We say, look, the electrons probably can be located somewhere in this area. And so all these dots are basically the possible location of one electron in hydrogen. And we just don't know. We just think, well, if you look at the density of these probabilities, it's probably closer to the nucleus in this spherical area, right? But that's all we know. And so we can only predict where the electrons are probably located. So what we're going to do is we're going to actually work on a lab called the Electron Probability Lab, and it basically shows how they figure out the probability of where these electrons would be located.